Okay, so we're going to do some applications of calculus here. And one of the applications that we're going to look at is linear approximation. And these are what we call numerical methods. So we're just kind of using calculus to help us approximate values of functions and what's happening to functions. Okay, so linear approximation basically works like this. We have a point here, a point on the graph, and we can find a tangent line equation, okay, that red tangent line equation, and we can use that tangent line equation to help us approximate values on the curve. So basically we're going to say that as long as we're close enough to this x naught, the tangent line will closely approximate points on the curve. Okay? So as we can see, as we get further away from that point, okay, the approximation will get worse and worse. Okay, but points relatively near that coordinate, the red line is a fair approximation of the black line. Okay, so if we just zoom in a little bit, oops, what just happened there? Okay, zooming in a little bit, I can't seem to zoom in, but so that tangent line approximation is what we're going to look at. So same thing over here, we can see that tangent line for close values of near that point of tangency, the red line approximates the black line, but as we get further away, the approximation doesn't look quite as good. So what we need to do to do this approximation is we need this tangent line. Okay, so we need to have the slope of the tangent line, and we're gonna, so there's our slope of the tangent line, okay, f prime, and then we're going to use our position of x naught, and that f of x represents y naught, and be more specific, f of x naught there. We're going to use that y position, this xy position, and the slope to get us the equation of the tangent line. And that tangent line value then, the y value, approximates y values on that curve at x naught. Okay, so we're at point x. So this is what we want to generate, is this equation, and then we're going to plug it into the equation to help us calculate our approximated values on that red line. Okay, so this is an example here for this one. So this is 3x squared minus 18x plus 18. Okay, we know that at x equals 0, y equals 0. Okay, and we can calculate the derivative. Oh, sorry, this is the derivative here. So this is our function x cubed minus 9x squared plus 18x. This is our derivative. And we're going to find the slope of this derivative at 0, and we get a slope of 18. So when we have that value, we can then just plug it into our tangent line equation to work out our tangent lines. Okay, slope x minus the x position plus the y position, okay, y naught. And then we're going to use this equation to calculate the coordinate, the y coordinate, at a point close to 0. In this case, we're using 0.2. So when we plug 0.2 in, okay, we're going to find the equation, the value of 0.2 by plugging into the equation. We're going to end up with 18 times 0.2 minus 0, and we end up with approximation of 3.6. Okay, so if we actually look at the actual value of that function, the actual value was 3.25. That would be that point there. Okay, 3.6 is one we calculated, which is a relatively close point.